think Mylan kind of came onto the scene around 2003, 2004, 1.0 was in 2006. And it has made, I think, a huge impact in the community for how people are using the integrated Eclipse into the software lifecycle. I actually met Mick kind of in the early days of Eclipse, in the early days of Mylan, and he has proven to be one of the leaders of the Eclipse community. So I'm really happy to have him come up and do our final keynote on really where he sees as the future of application lifecycle management and how all the tools that we use are going to evolve in the future. So with that, I'd like to invite Kersten on stage for the future of ALM.
Thanks, Ian. Hi, everyone. So what you're seeing here in this keynote will be looking forward a lot. Here we're looking back at the last 5 years of Mylan history. And this is actually not a commit graph, which you might have seen before. This is a graph of the collaborations. The bigger people are, the more they were doing, the more activity they had, the closer they are, the more they work together. So I'll explain a little bit more about that later in the talk. But we're all here because there's something we love about building software. Yesterday we saw how much software is changing a lot of the things that we interact with daily. In the IEEE article called This Car Runs on Code, we learned recently that cars of today have 100 million lines of code. So we went from 0 to 100. The cars of the near future are going to have 300 million lines of code. So that's a pretty big increase. And the other really fascinating thing is that it's not just the car vendors creating all that code. So one of the larger car makers I've been working with has 4 dozen software suppliers outside of itself. When it does a test drive, when they find defects in that car, those defects have to be sent to 4 dozen different organizations all over the world. And then the defects are fixed and flow back into the car. So we've gone away from this sort of simple way of building packaged software into something that's becoming a pretty complex software ecosystem, involving many organizations, many parts of an organization, and involving different kinds of software delivery. So a lot of us are familiar with open source delivery. Open source software components are being consumed as part of this broader supply chain. We're seeing a lot of outsourced delivery in the developing world. So at Monday's Eclipse board meeting, Mike Monkigras showed some statistics. And I've been seeing these Eclipse download statistics for years now. I've never seen this big a change from year to year. We had, on average, so this time last year, we had around 1.4 million Eclipse downloads, so download requests from the Eclipse site. This year, there was 2.4. And it's always, for those of us who watching these graphs, it's been increasing in these last 10 decades, one decade of Eclipse, I should say. And we've recently seen this big spike. And when Mike kind of zoomed in on some of the statistics, what we saw is that Asia caused a really big chunk of that spike. So there's a lot more Eclipse downloads happening in Asia. Android tools could be responsible for a big chunk of that spike. There's a lot of, with a couple 100 million Android devices, and then the Android tools being built on Eclipse, we're now seeing Eclipse spike up in terms of downloads. Germany used to always be one of the top downloading countries of Eclipse. Vietnam is now approaching the size of Germany. And I'd never, ever seen Vietnam anywhere on Eclipse KPIs before, the Eclipse download stats. So the way that Eclipse is being used and the way our components are being reused and consumed, the ones that we're producing as Eclipse committers, is actually changing fairly dramatically. And there's a lot more software delivery being done in the developing world. It's not just QA that's being outsourced anymore. I think a big chunk of that spike of the downloads has to do with the fact there's a lot more software development and delivery being done in the developing world. And then of course, these mobile platforms, cloud, they're transforming a lot, and they're really accelerating the rate at which software is being built. So our workforce only grows linearly. In the US, the workforce, I actually looked at some census stats. In the US, the workforce is growing pretty slowly linearly, which is why we actually need to get software delivery capacity from the developing world. There's just not enough. The amount of software, if you think about how much is in your car or in the planes on every device that you have, is growing, I think, more than linearly. It's growing exponentially now. or at least it's on a steep curve. And Mark Andreessen, this summer, I think, shot a pretty important flare into the sky, and he said that software is now eating the world. Traditional companies, which you think of as companies like FedEx, now think of themselves as software companies. So the volume of software that we have is increasing, and it's increasing rapidly. Our workforce is not increasing rapidly. It's increasing linearly. And at some point, we're just not going to be able to deliver on the demand for that software. Now, if you're a developer, this is pretty good in terms of your job prospects. But there's another factor that makes this, which you might be feeling, which makes this a little bit more annoying. Because as the amount of software grows, the proportion of time that we spend on software maintenance has also grown. So right now, we're at 70%, and that number is growing. So even though our job security is important, I think we want to avoid the world where in 10 years, we're spending the majority of our time on maintenance of this morass of software rather than on innovation. Because it's that innovation that actually drives competitiveness now in companies. Car companies are differentiating themselves by hiring more and more software engineers so they can innovate on the software front. Last, at EclipseCon Europe, BMW had a booth for the first time. So we've seen different approaches to scaling production. And in this Taylorist world from the Industrial Revolution, we figured out how to basically make people be like cogs in a factory and have them assemble components. You can simply throw people at the problem if you want to scale up, if you want to get more efficiency, if you want to do more with less. Apple can do this with Foxconn, right? You just get more and more workers. The problem with software is it's a creative industry, and it's not this algorithmic activity, it's a heuristic activity. And these creative activities don't scale that way. You can't just throw more people. You can't double the size of your development team overnight and then expect your capacity to double. Creative industries don't work that way. So this approach to solving the problem is not working. It's not going to work well enough. It wasn't even working well enough in car manufacturing, and Henry Ford realized that. In 1914, he took a step to treating people slightly differently. He realized that there were enough workers leaving the Ford factories, and there were enough suicides happening from this way of treating people, that he changed his approach to treating workers. So he actually started investing in workers. He did this interesting thing. He doubled the salary of his workforce, and he made the salaries twice as high as his competition for his automotive manufacturing people. And Ford after that skyrocketed. And this was an economic decision. It's actually helped him differentiate. But what he did is he actually empowered the workers. He trained them for the first time. They were thought of as a little bit more maybe than cogs in the machine. He trained them, he empowered them. He did not empower them with any decision making. He just empowered them in terms of knowledge, becoming skilled workers. But all the decision making was still centralized. Then to compete against the American manufacturers like Ford and GM, later on in the last century, Toyota did this really interesting thing, which many of us know as agile. But they started automating everything. And the Toyota production system, they came up with this idea of just-in-time manufacturing, and I'll get to that a little bit later in the talk. But they did something else for their workers as well, and it translates to automation. So in addition to automating everything, so you could have visibility and transparency across this production process, they actually empowered the people with decision-making all the way down the chain. So any worker on the assembly line could stop the entire assembly line if they saw something going on, something that was wrong. And they called this automation because everyone in the production process, every person had autonomy. They were a decision maker for their level of the production process. And this kind of led nicely into, I think, what Peter Drucker's shown us, which is that in these creative industries, in knowledge work, for each knowledge worker, we have to understand the task, and then we have to give these workers autonomy. We have to empower them, and we have to empower them to be responsible for their own productivity. We have to let them manage themselves. And we have to, this lines up very nicely with some of the more recent concepts we've seen in more popular literature, such as Dan Pink's books, Dan Pink's book about drive. We have to empower these people. We have to give them the capacity to execute on their tasks. And we have to give them the ability to manage themselves. Now, so those are some of the great thinkers of the last century. I think one of my favorite thinkers of this century lately has been DevOps Borat, who's had some really great insights on how we're doing some of this. So we're in DevOps, they're only communicating with Jira tickets. And we'll get back to these 2 points and reconcile them later in the talk. I'll try anyway. So this talk will be about the fact that we need autonomy. And we're just not happy as creative workers if we don't have it. And we're much more effective when we do. About transparency. So we'll be talking about how in open source and Eclipse, transparency and autonomy have played together and have produced some pretty remarkable things. And how this has fueled collaboration. And then collaboration, how this feeds into this social code graph that's forming and actually transforming the way that we're building software. And I'll show you some examples of how that's going on in Eclipse and a bit beyond Eclipse as well. So right now, just looking at the present, in large-scale software delivery, we're stuck inside these silos. So we've got different roles in the organization. We've got different rates of change. We've got different sets of tools that we're using over here. Developers, we've had a ton of change in the tool set that we're using. We started getting these open source issue trackers like Bugzilla, then commercial versions of similar things like Jira. Then the agile tools came, tools like Rally and the like, and new processes like Lean that enabled more and more collaboration and transparency within our silo. In terms of business analysts, we kind of expect them to live in Microsoft Word and talk to us through epics now and then. There's no automated connectivity there. Project managers, we're touching on them, but it's still a different tool set. So the tools developers like, the very lightweight issue trackers, are different than the tools that project managers like, the sort of agile whole project views. Testers, we just tend to throw things over the fence to them. And ops, we're still learning about, but usually they're just responsible for standing up our administration. It's just a separate part of the organization. We've siloed ourselves, especially at the large scales. So if you've got thousands of developers, this is much worse than if you've got 10. And these silos are causing problems. So DevOps Borat says he thinks it's ridiculous when there's silos in place. He just prefers to have an NDA between operations and development. And this is unfortunately a little bit too true. Yeah, there are going to be a few of those. So we've got these silos have created some cultural gaps as well between these different organizations or parts of the organizations. And this is just a little graphic Alan Cooper tweeted recently of how we see each other. So developers obviously see developers as basically rocket scientists. We see designers as a little bit more lazy. And then we're seen by project managers as, again, just cogs in a big factory chain who should just get things done without complaining. And we've got project managers. We see project managers as perhaps a little lazy and pointy-haired. And project managers, of course, see themselves as running the world. So then Agile falls into the loop, explaining what a Scrum Master is to an Agile Agilista. Or, to a new DevOps person. DevOps Borat indicates it's something like a tooth fairy. And often we don't get too far beyond that. So this is causing some real problems and some really expensive problems. This is this beautiful piece of machinery got delayed over and over and over again because of some of these problems. So I saw this article go by in 2008, and I don't think it got that much attention. But it was the general manager of the 787 project who just said it's going to be delayed another 6 months. He said another few months. I think it turned out to be around 6 months. And he said it's not that the brakes don't work, which is good. It's the traceability of the software. And this is not the kind of thing that you usually see in a press announcement around the delay of a very expensive piece of machinery. What happened, so I looked a little bit more into the story, what happened is that Boeing had the requirements for the brake software. It has to not overheat and stop the plane and do these other things. The development of it was outsourced because, again, we've all got these capacity problems in terms of how much we can deliver. And so the requirements were pushed off to the organization that did the delivery. They were It was a subcontractor, General Electric. They delivered the software. Software worked beautifully. The software passed all the tests because all the tests were spec'd. But when they threw it back over the fence, they didn't have any traceability. Because again, we were just handing these things off between the different stages of software delivery. They had no traceability between the requirements and the source code. So the thing that on the Mylan project and a lot of Eclipse projects, we just rely on the fact that from the Bugzilla bug, there's always a reference back and forth to the source code that we can navigate. They didn't have that because they were tossing the code over the fence. And when you've got this big chunk of machinery that you need to maintain for 70 years, so let's say 35 years operation and then 35 years maintenance, the thing is going to be flying, it gets pretty expensive to not have that traceability. A requirement changes, there's a defect in the source code, you need to know which requirement it affects. So Boeing has a much better perspective on this kind of long-term cost of software maintenance than most of us do. So they did the rational thing, which is to throw out the brake software and delay the plane to rebuild it. Because it would have cost more over time to maintain the plane without that traceability. And I think a lot of us are, again, their software delivery process is mature enough to account for this. A lot of us are building up all this technical debt, all of these problems in our source code by doing this kind of handoff things, by throwing things between the business analysts doing requirements, development doing their own thing in their agile way, and then testing. And it can get very expensive. So let's just take another look at how these kinds of handoffs, how we're doing this larger scale software delivery. We've got requirements being done by the business analysts. So we've got developers who then crank on these requirements. There's some testing being done after the fact, maybe earlier on if you're trying to be more agile around your testing. And then there's the operational life cycle. And as I was going through this, I was trying to think, so there have been a lot of great books on lean thinking lately, books like the Lean Startup, and in the whole lean manufacturing process, it all boils down, this whole idea of just-in-time boils down to reducing your inventory. I was trying to think about what is our inventory in the software delivery process. It's not, it's not bolts, and it's not jar files, I don't think. When you think about the inventory that business analysts build up before it moves on to the next stage of production, it's requirements, right? It's this Word document or hopefully some other tools view on requirements that then get handed off to development. Development does their thing, then it gets handed off to testing, possibly on another continent, and then it comes back to operations. So the whole problem at Boeing story is that we end up with these things called very large batch sizes. When you have large batch sizes, you've got this long cycle, and you get these sorts of problems because there's no communication between the stages when you're doing these big handoffs. And I think the great stories in some of these books, like the Lean Startup, like Lean Thinking, is what happens when you reduce batch sizes. So let's say that you're sending out Christmas cards, but you still do that manually. I think our intuitions often tell us that the fastest way to deal with Christmas cards, I really don't like dealing with Christmas cards, but I've always done it this way myself with my wife, is one person signs, you print them out, one person signs them, and you sign all of them, then the other person folds them, then maybe you have like a DevOps person living in your house and they lick the envelopes, and I'm still learning about DevOps. Then you close the envelopes and you put the stamps on. And that turns out to be a slower way of doing it than if you do all the steps yourself. So you basically split it up, and everyone does every step themselves. So you sign it, fold it, seal it, and so on. Because we always underestimate the time it takes to do the handoffs and to do the sorting between the stages. And what Toyota proved in manufacturing, and this experiment has been done with envelopes, by the way. In the book Lean Thinking, you can look up the results of that. You can read through that experiment. It's actually faster, even if you're not making mistakes. It's faster not to batch it up to a small batch sizes. If you have a problem, like you're missing some bit of traceability, or you wrote down everyone's address, you print out everyone's address wrong, chances are you won't realize it till a later stage in the pipeline that you've created with these large batch sizes, and then you've just completely blown away your efficiency. Which is why, again, that decision-making process, that anyone going through this process could instantly stop the Toyota production line, was so important. So this is a lot of the agile lean thinking discussion talks about this. To us, building on Eclipse, this is nothing new. 10 years ago, the IBM teams, the teams from OTI, gave us a process for working this way that a lot of Eclipse projects have emulated. Just nightly builds, very short cycles. You're not batching things up between teams or between different organizations. The QA there's some crowdsourcing of QA on Eclipse, obviously, but the quality is the responsibility of the core development teams, and you end up with these very small batch sizes in the delivery of almost all Eclipse projects. There's a coordinated annual release, but almost every project has milestones that range from a week to 6 weeks. So that's the biggest we let our batch sizes get. It's not months. And I think the way to think about this now, and the way to think about optimizing it as we try to move beyond, to basically scale things like the Eclipse process, these more lean processes, into a bigger picture of lean ALM, lean application lifecycle management, is to think about reducing the batch sizes across those silos, not tossing things over to QA, not getting a list of requirements, implementing something, realizing the requirements are messed up because the developers will often know what's possible in the software, or they'll have, there's a lot of creative process in development itself. And if QA, 6 weeks from now, you get a list of 80 bugs in an Excel spreadsheet, half of which are no longer relevant because you've completely changed the software because you're running lean in development, that's a problem. You've got a lot of waste. So I think a lot of it is around going from these large batch sizes of tasks and handoffs into these very small batch sizes. And then the small batch sizes mean you're collaborating. You're not tossing things to the other side of the fence every 3 weeks or every 6 weeks. So let's take a closer look at how we've been doing this at Eclipse. We've got, just quickly in terms of scale, for Juno, around 60 million lines of code. Not all in Git, but CVS is being sunset by the end of the year, so we're getting there. Bugzilla's got 375,000 bug reports, which are our tasks, 337 build plans in Hudson. We're just ramping up on Gerrit, so 6,000 of those. And what you'll notice is that each of these tools that we use on Eclipse has been this labor of love from some of the key leaders in open source, right? Linus gave us Linux. He gave us this, I think, even more important thing, which is Git. It captures his way of interacting, his way of communicating in very small batch sizes to his lieutenants and to his ecosystem. And even though it's insanely complex, it's just a much better way of working. We've got Bugzilla, again, has all been around supporting collaboration. That social graph I showed you at the start of the talk that was playing, that was all based on Bugzilla comments. And we'll take a closer look at that soon. But that is how we collaborate. That's the social structure behind the software that we're building. So Hudson and Jenkins, all of these tools, and Gerrit, they've all done this thing that I think aligns very closely to what Drucker's shown us. They've all made it very easy to capture the task and to pass it on to collaborate on it. Whether what you're doing is you're making a commit and a branch around it, whether you're building it, whether you're doing a code review on it, to bring in someone else's ideas into the source code base, whether it's someone internal to your team, someone from the community. And there's one other thing I don't want to undermine was actually making Eclipse run, because the operations side, I think we've got one key DevOps person at Eclipse that nothing would run without. So Denis Roy's got the biggest stat. He's responsible for getting the software out to the world at a rate of 35 terabytes a month. So those Eclipse bits dominate the bandwidth usage, and that's what's getting shipped everywhere. And the neat thing with all these tools is they all have this first-class notion of the task, not just the source code anymore, not just a source file or a bundle of source like a jar file. They all have this notion of tasks. The tasks have a workflow, but they also have a social activity stream, and they have a context. So they're richer than this notion of a to-do list or a user story that gets broken down into subtasks. They've got different types of the requirements, defects, user stories, plan items, epics, whatever you call them, or whatever we call them, whatever style of delivery the team chooses, like Scrum. They have this process. What's more important is that they have this activity feed. Right now, it's mostly asynchronous. It's mostly comments on defect. It's mostly patches pull requests, all of those things, but all those activity streams attached to a task. And then we're increasingly seeing these social streams as well. So being able to incorporate a social stream, like Tweet, like more of that kind of broader communication with a user community into tasks and feed that back into this thing. I think we should think of as this graph that layers on top of the software that we built. And the documents, the source files themselves, links to everything else fall under the context of this task. This is really just, this is what Mylan's model is, how it hooks together all those other tools on Eclipse and makes it easier to work with all of them. So what's been really interesting is the way that these tools have been evolving together. If you look at the way that we've been doing planning, and the reason why the distributed version control has been so important. So I think the reason why Chris Anderson's been so excited to move everyone to Git, even though he's the first to admit that there's some growing pains there, is that what we see in our planning cycle, where we've got things like product and user stories and these tasks that correspond to software units that we're building, we get to see reflected in our version control system. So we can create, we've got these commits, they're not lost. We've got topic branches that are really easy to create for each one of those units that we want to deliver, or we want to get code reviewed, or we want to collaborate around. And again, have different, different sets of products line. We're able to capture that breakdown of work as tasks. We're able to see it both in our issue tracker, or our planning tools, and in the source control. It's one of the things that's fundamentally critical about moving to a system like Git. So as we're doing this, we're seeing the tools that we're using, the software that we're using, get built, get picked up. The teams are very effective at doing it. If you've ever tried to consume an Eclipse project, your experience might be a little bit more like DevOps Borat. So we've got this collaboration. It's mapped into the source code. But it can be, there's still these very large barriers to entry. And we've been doing a lot on Eclipse projects to reduce those barriers to entry because we realize that we're part of this bigger software supply chain. Our experiences on the Mylan project, we've got 70 different ALM extensions for Mylan, with all these vendors trying to consume it, add patches to it, being able to incorporate their feedback and really the things that they can add to the project, like when they want something, not telling them, okay, we'll do it, but telling them, okay, do it yourself, has been vital to seeing that project evolve. And you actually saw that in the history for any of the Mylan committers. You'll actually see these people who were started extending Mylan to different systems would come into the project, can contribute a bit, get what they wanted, leave, and so on. It's part of the social fabric of the project. So what we've done recently on Mylan, if you saw Benny Muscala's and Stefan Pingel's talk yesterday, is to automate some of these processes. So basically to take the different tools that we have on the application lifecycle management side and expose not just the source code, but the application lifecycle management to the community to make it easier to consume and contribute to. So one example of this is this new contribution workflow we've been creating around Git, Gerrit, and Hudson. The problem we have is that, like DevOps Borat, people who would give us patches to Mylan would give us patches that would just never pass the test because they wouldn't take the time to run all the tests, to set up their workspace for all of this. We would always be reviewing patches that just didn't work because there was too high a bar to getting set up with the open source project. And if you've ever tried to get set up with another open source project and taken the time to spend the 3 days downloading libraries and setting up builds and Maven and figuring out what's going wrong, you have a sense for this. And it was causing us waste. Again, we needed this part of it to get more lean. So the first thing is to automate, then to reduce those batch sizes. So we put in place this process, and you can get the full demo. I'll give you a link to a video later. But basically, a contributor comes, they push their change into Gerrit, and then that's pulled by Hudson. So they've got an idea that they want to change the way an icon looks in the Mylan user interface. There's a code review created, a separate branch created. Hudson builds it for them and runs it against all their tests from their workspace. They might not even have it, they should have it compiled probably because it would likely fail otherwise. They didn't need to. They were able to push it and to connect to Mylan's lifecycle. Mylan's application lifecycle management tools. They had their own private, private branch, private build instantiated that gets built. If Hudson built it and all the tests pass, it +1s it. So it says, this thing passed. It's now ready for a later stage of review with no interaction from a Mylan commit. Then the Mylan committers notice, OK, well, there could be something cool here. If they like it, they like the way that icon looks, they can +2 it. It'll take 2 of them or one person feeling strongly enough that they'll put a +2. Or they'll say, check out this icon right on the code review. But that code is then live. It's working. It's no longer just separate workspaces. They're actually connected to our lifecycle. And then if it gets blessed, it gets pushed into Git and pulled by the team. And then the next day, it can be in the hands of tens of thousands of Mylan users for consuming the nightly builds, because they'll just get picked up. So this kind of automation that we can hook up, because all of these tools are speaking the same language of tasks, is how we've been taking this approach to automation. It's how we've been making it easier for consumers of our tools to hook into our lifecycle. And I think it's really necessary, especially when you think about how these tools work. Git, Gerrit, Hudson, you might still be just wrapping your minds around it. In 1995, DevOps Borat said you could fit the whole internet in your brain. In 2011, you can't even fit Git in your brain. So if we don't have this level, these tools like eGit, this level of automation that, when we're activating a task, branches are created, code reviews are created, we're actually exposing all of the power of that tool to the entire user. And what's really important is the consumer base, the people building on our software, because we need people building on our software to make it successful. And again, causing these barriers to entry, causing these silos that prevent collaboration. So I think the way to look at ALM going forward is that first we have to put in place this automation between these tool chains, and especially getting these tool chains to break between those silos both within the organization and outside in this software supply chain. People consuming your software, if you're an open source project, need to be able to plug into that lifecycle, need to be able to see when there's a new defect, need to see if a requirement changes. And not only in open source, right? If you did that supply chain from the car manufacturer, those were suppliers who were using one issue tracker, while the car manufacturer was using an enterprise-grade issue tracker, let's say. So we'll take a closer look at that in a minute. But I think the key thing to think about is what the artifacts, what the collaboration artifacts are between those silos, because we need to give those artifacts an activity feed, a proper social feed. It's not people and watching their photo updates. It's, between project managers and developers, it's usually things like user stories, if you're doing Agile or Lean. Between testers and developers, we've got things like defects. That's what they collaborate on. They need to do that on a real-time basis, not on a 6-week interval or 12-week interval. Requirements between business analysts and testers, cases between operators and developers, and things like epics. These are some of the new vocabulary, and this is obviously only just one slice through it. But these are some of the things that we need to automate. These are some of the things that we need to connect. So now I'm going to show you an experiment that we did at Tasktop a little while ago of looking at basically what's in these silos, taking some open source projects and looking at how this kind of collaboration worked in practice. So all we did is we took the Tasktop Sync tool, which takes the Mylan data model, and we connected the Mylan data model to the Spring IDE open source repository, the Spring closed source repository, which is open. It's an open Jira, and the bugs eclipse.org repository. And then we took a tool. This was done, the demo here was done by Miles Parker, who built the tool, the Eclipse-based tool called Butterflizer. So this is also all an Eclipse-based tool as well, both building on Mylan. And let's take a look at what we got. So this is similar to the thing that you saw at the start of the talk. The bigger a person's name is, the more tasks they have assigned. The tool is processing in the stream of Mylan task data. It's processing the comment streams. The more people comment with each other, the closer they get in the graph. So the more they collaborate, and that's all it is. That's the only structure that we're showing right here. We've experimented with different views on this. This turned out to be the most interesting. So let's actually look at these different task catalogs that we have over here. If we look at just the server tools, we see one repository, one project area. There's Stefan Pingle, who works with Christian Dupuis. These people work in a few different organizations in this Jira. If we look at the Spring open source tools, let's unfold those. So we're processing these comments. And what you'll see, what's neat to see on this is, especially if you see your name up there, because there are quite a few people's names who are sitting in front, who are up there, like Martin Lippert works with Christian a lot. And we see these groups forming within the issue trackers. These are groups just based on how people are collaborating. There's no source history here. Now, this actually maps very nicely to the source history to views like Gore's, but we see some even more interesting things right here that are hard to find in the source history. So here are the Virgo tools. This is another Eclipse project. And there's Miles Parker, who's actually quite closely involved in that. Now, I'll take two different projects. And these are now, we're now looking at both, and it'll take a while to unfold itself and to process all the comments. It's a little messy. I'll take a Libra and Virgo and Spring open source tools. So now we're looking at two different open source repositories. And you'll note that the people's, by the way, these blue circles, these are bunches of tasks, if I mouse over them. So these are Bugzilla bugs or Jira issues, because all of the collaboration is happening through those Bugzilla bugs and Jira issues. And we see collaboration happening across these open source repositories, because what we've got here is an open source software supply chain that's actually folding into what's now currently a closed source tool. So the Spring Source tool suite is built on open source components. So it builds on the open source Spring tools, Spring IDE. It builds on some of the Virgo tools, which are on Eclipse. Builds on some of the Mylan tools, which are also on Eclipse. Builds on the Libra tools on Eclipse. And unlike what you see with a lot of open source software consumption today, it's not just the source code that's being grabbed. It's not just a copy of the source code. If there's a bug in Virgo, if there's a security flaw that comes out in the DM server tools or in some of the Virgo tools, that will be exposed to the Spring Source tool suite team, to the team doing the commercial plugins, because they're hooked into the lifecycle. Not only that, but these people are connected. So you see actually Glenn Normington is one of the key people connecting some of the open source efforts and the closed source efforts. And again, if we take all of these different systems, we'll see all of this unfolding itself in this very nice way. So we're actually seeing this social code graph based on people's collaborations. I'm going to unfold it a little bit more for you over here. And one second. And we're seeing that it's self-organizing. We're seeing that these people's collaborations actually span two kinds of organizational boundaries. They're spanning the repositories that they work on. So this is basically units of organizations, like think of them like an org chart. They're spanning any product boundaries. And they're creating these self-organizing teams. And what's fascinating about this is that many of these people have worked for different companies. So they started working. I started working with Christian Dupuis, who's one of the biggest labels up there, while he was not yet at Spring Source and later VMware. He started contributing to this open source project. Same with my work with Stefan Pingle. So these people who saw something interesting in open source, started collaborating with that team, have then become a part of that organization. If you think of one of the core pieces of Eclipse, so Eclipse SWT, and you think where Steve Northover and Scott Kovacs have worked over the last decade, their relationship transcends IBM, Oracle, Apple, Badara, a very large number of companies, the way that they've been interacting on this. And one of the most fascinating things I find about, I've been staring at this a lot lately, and one of the most fascinating things I find about this is that it's breaking Conway's law. So Conway's law is, Conway came up with it when he first opened up an IBM PC, I think at least that's how it happened, and he saw on the motherboard IBM's org chart. And he came up with Conway's law, which is that the way that we produce things reflects the organizational charts that we have, that we create within our companies. Because we're basically putting these silos around people and around teams. One of the key things with Agile is that you push self-organizing teams. And the thing that you see in open source is it's just blowing away those organization boundaries. These people have autonomy if they are consuming a framework from Eclipse, they have the ability to create a patch from that framework. And 1 in 1,000 might actually create that patch and then get interested in that project and start collaborating and building these trust relationships with that project. And that's what we see happening here. These collaborations, because these repositories are open, this would not work if the repositories were not open and transparent. But because these repositories are open, people can pursue their interests, their need for software production, and basically change the org chart from under them, change who they collaborate with. And these changes in the last 10 decades of Eclipse, they've transcended the company boundaries and those org charts, which means that the people who've collaborated here have created new projects. And they've created these new in some of these projects, some of these open source projects, get adopted very broadly, right? Some of the tools that you'll see here will be the underpinning of products created by the developing world there. So these teams who are just pursuing their interests in open source, pursuing this whole notion of autonomy and mastery that Dan Pink has been pushing, are actually defining the new landscape of products that we're using. And I think this is the kind of pattern that we need to bring into our organizations when we look at our own supply chains. Because for most of us, they're not like this. They're not this big set of open source repositories where developers can pursue their interests closely and teams can self-organize. So what we need to look at is what the social code graph is illustrating. This need for autonomy, transparency, and collaboration is making these hyper-productive teams delivering open source software at a rate that's much higher than what we get in industry. And there's been a lot of attempts to emulate that within organizations. And since this is a social code graph that's based on collaboration, none of this works. Again, none of this works with the large batch sizes, right? None of this works if you keep now that with PaaS coming, deployment is becoming a core part of the developer's workday, continuous deployment, and the architecture of the platform as a service that you're using. If you think of the application operator, the administrator, as someone who you're just going to toss things to, this won't work. We know some laws about social networks. So the first one being Bob Metcalfe's law, that the value of the network is proportional to its size. The more people you add to it, the more valuable it becomes. More recently, there's laws like Reed's law, which point out that the value is actually much higher. So it's exponential. It's 2 to the n because groups form in the network. The value of the network is not just everyone being connected, but all the subsets of connections. And companies like Facebook know this very well because it turns into dollars for them. The advertising companies leverage this. They're advertising to these groups of interests. What you saw in that social code graph a moment ago is these groups forming once the graph is opened up enough. And this is what we need to leverage, this ability for groups to form serendipitously in the network. So it's another network law from DevOps Borat, which says that the number of GitHub projects you contribute to is inversely proportional to the number of conferences you attend. So I know what we're all doing here. But to support this, we need to, and I think it's important that we think about how we support on the personal level, on the organizational level, and then in terms of the big picture. For those of us building tools, how we build those tools going forward. We need that autonomy, the transparency, and the collaboration to do this. There's this interesting corollary to Reed's law. And by the way, the actual value, this gets argued quite a bit. Even Eric Raymond's arguing against Reed's law, that the value of the networks is somewhere in between there, but it's large in terms of the number, and it's based on subgroups. What's really interesting is that the value of exclusion of the network is being noticed as a problem. So once you've got a social network, if a chunk of it is disconnected, constituents that should be in it are not, the negative value, the negative utility that's introduced is also exponential. So if you've got this network, let's say you've just gone through your agile transformation, and you've done that all around development, right? Your development's now agile. If the endpoints of operations is not working that way because they're actually upset because you're shipping so often, or requirements is not working that way because they only like to update their Word documents every 2 weeks, the theory of constraints starts to apply, which means that the theory of constraints is that the weakest link in any chain is going to be the bottleneck of that chain. If we don't have this social fabric, this collaboration ability, and this move towards small batch sizes extend outside of development, then we're not getting those benefits. We're excluding constituents who are a key part of delivering software, whether it's defining what it does, testing it, or making it run. And we're not getting those networking benefits that we already see in projects that basically, where the person, where the product manager, the quality engineer, the developer are all on the same team. And that's what's happened a lot on these open source projects. This is a harder problem to solve in software delivery in the large, but I think this is how we address it. And I think that's why these conferences where we bring together developers and other stakeholders are so important. It's no longer that we can, if we only have conferences of project managers focused on project management, like the Agile conference, or conferences focused on developers, like most EclipseCons have been, we're missing this picture. We're missing these conversations. They're going to change our landscape and our tools to make this work. And I think we need to avoid this kind of landscape being where we are 10 years from now. So this is the Web 2.0 Summit map of social networks. I've just highlighted only the social networks part. But if we end up in ALM, if we think of where the future needs to be as this one social co-graph around our software ecosystem, around the whole supply chain that you're consuming, if it's closed, it won't work. We already know it won't work because we have this huge broad range of ALM tools, this huge amount of heterogeneity. If we end up in this world where it's just Facebook battling with Google+, we won't get this because that exclusion and the fact that we need best-of-breed tools for different stakeholders will just collapse the value of the network. So it's not enough for it to be called an open graph. It has to actually be an open graph that supports a wide variety of vendors and open source projects. And so just to wrap up, I think in terms of thinking what we do as developers, it's actually good to think about growing your network, both inside your organization and pushing for transparency inside your organization, if it's not there, because that's what will create the self-organization, or outside. A seventh of Mylan was created because people were frustrated with their day jobs and just contributed to Mylan, because they didn't have that kind of transparency, autonomy, and mastery that they wanted, so they contributed to open source instead. So insisting on this transparency and this visibility across components in your organization is how we're going to break the limitations of Conway's Law. For managers, think of every developer as a volunteer. That's what works in open source. That's what Peter Drucker told us to do. Every knowledge worker should be thought of as a volunteer, and you end up with a more effective process. And embrace the self-organization and autonomy. And then for tool vendors, embrace these more complex ecosystems, the fact that it has to be open, the fact that there can only be one Apple right now. We need to support heterogeneity and make these tasks the glue. So there's more information here. We've got some of the stuff on our blogs and upcoming webinars. And thank you very much for listening.